So in this lecture, we are going to talk about Internet of Things, its overview and architecture. So what exactly is Internet of Things or IoT? So IoT basically means connection of different things with each other using local connection or internet, right? So things are basically the devices here. So your normal devices, like it could be a fan, it could be a light. Of course, your mobile is also a thing. All right. So somehow making these things interact and connect with each other, that is only IoT. Now, of course, these things have to be connected to each other using some protocol. So either we can have some local protocol, or obviously we can always use the global connecting protocol, that is the internet. But yes, internet is not mandatory here. This is an important point that you should remember. So we can use some local or non-internet protocols like IR, like RF, okay, or you may use Ethernet or Wi-Fi, but without the capability of internet. Of course, internet will be required if you don't want to control or you don't want to connect your device only locally. That is maybe in your house or at your workplace or at college. Alright, so of course, if you want to do remote access, if you want your devices to be connected even remotely to you or to anything else, then yes, internet will obviously be required. But internet is again not a mandatory requirement in case of IoT. Alright, so basically we have things in IoT. So as I have discussed already, what are things? We will also discuss in a while how these things can be created. How can we take a simple object in our day-to-day life and we can actually make it IoT compliant, or we can basically kind of IoTize it so that it can connect with other things. Alright. So we have different things that people should be able to access as well. Right? So the things will be connected to each other, say a fan, light, AC, washing machine, and the people should also be able to get access to those things using some protocol. All right. Then we have some cloud services as well. We can have certain cloud services. This is optional, not always required. So what are cloud services? Cloud services basically, these are services, remote services that gather your data and they can do some processing based on the data that is available to them. Alright, so let us see this in detail. What are each of these things? So when we talk about the architecture of IoT, we have users. What are users? Users are the human participants that use the service, or endpoints. So endpoints are basically your things. What are things? These are the physical or virtual endpoints representing a data source, sink or both. Data source means it is sourcing some data, sink means it's accepting some data, or a thing or an endpoint can do both. That is, it can be a source and it can be a sink. Then we have certain services. So like we saw in the definition of IoT, cloud services. So services are not always required, but yes, you can improve and add on a lot of things to your IoT architecture or whatever IoT implementation you're doing by using some cloud services. So basically they are going to provide tools for data analysis, for carrying out certain actions based on the data received. Alright, so let us just take an example. So if we are talking about your mobile, see, your mobile is also a thing. Your mobile can connect to a lot of services. Alright, so mobile can access a lot of services, and of course you can access your mobile, you can control it, you can provide various options, you can install different apps, you can change your settings. So yes, your mobile is also a thing here. Now let us talk about some other object, maybe a washing machine that's in the house. Yes, washing machine can also be converted into a thing that can be used in IoT architecture. Alright, so if I convert it into a thing, obviously I'm going to require some sort of communication protocol. You cannot just directly connect a washing machine to your mobile just like that. Of course, it's not possible. So it needs to have some sort of communication protocol so that you can access it, you can communicate with it. So if we talk about some more examples, so suppose you have a device at home that measures the temperature in your house, or maybe it measures the temperature of some room or some other device that you want to monitor. Alright, so of course it will be able to communicate with you using your mobile if you have put some sort of maybe wireless communication protocol in it, like Wi-Fi or Ethernet. You can receive the updates on your mobile. That is always possible. So that is kind of a communication between the user and the thing, right? You also actually have a thing, but yes, you are able to monitor and you are able to receive information. Maybe you can push some information to that thing also, like when you select some modes on your air conditioner or your washing machine. So that's, yes, that can be done wirelessly as well, okay, as a part of IoT. But where do the services come into play? So if I start utilizing a cloud service, so there are a lot of services available nowadays. You have AWS, you have IFTTT, you have Blink. So a lot of services are there. Many of them are initially free, or they give you access, limited access, and then of course you'll have to pay for it. So again, going back to the temperature example, so you can monitor the temperature of your device using the IoT thing that is deployed in your room or in your house. But what if I want a kind of a graph? Maybe I don't want to check the temperature again and again. I want that on a daily basis, a graph should be plotted, maybe every hour. So that will show me what is the temperature of the device that I was monitoring. Okay, how is it changing, right? Or I want this information to be stored in some files that will be mailed to me at the end of the day. Okay, so of course you can also develop such applications, you can also write your own programs, you can do your coding, and yes, you can achieve this effect. But there are already pre-established services that provide all these kind of features. Yes, you might have to pay for them, but yes, they can provide a lot of features for which you will have to invest a lot of time, and you will have to invest resources as well. Okay, so there the services come into play when we want to do something extra with our things or our devices. All right, so ultimately you have users, things, and services. Services are optional here. So this is the whole IoT overview and architecture. But before concluding this lecture, I would just like to go a little bit in depth in the things. So if we have a thing like a light, tube light, or a fan, or a washing machine, air conditioner, how can we exactly convert it into an IoT thing? So how should, or what modification should we do in that device so that we can start using it in an IoT environment, right? So that brings us to the concept of embedded networking, which I have just called it here IoTizing. Basically, you are taking a device that is not an IoT thing, it's a normal device, and you are trying to make it a part of the IoT architecture. So of course, as we discussed, the things will communicate with each other using some sort of communication protocol. That's how we can make it an IoT thing. And that communication protocol could be anything. It could be RF, it could be Ethernet, it could be Wi-Fi, it could be infrared. So this is just one of the examples that comes under embedded networking. So here we have a microcontroller unit. So microcontroller unit means if you talk about any device at your home that is an embedded device, embedded system, it is going to have a microcontroller unit, right? Your AC, your washing machine, microwaves, even your mouse, keyboard, etc. Okay, so everything is going to have a microcontroller unit. We just have to add on some sort of additional device that is going to give our existing device the IoT feature. So for instance, here we have added an Ethernet controller. So of course you cannot do it directly to your washing machine or AC, but this is what I'm trying to tell, that if we have any device that we want to make it an IoT device, yes, we'll have to add on certain wireless protocol mechanism to that device so that it becomes a part of IoT architecture. So this Ethernet controller is giving a communication protocol to this existing microcontroller unit. So if we have an Ethernet controller, obviously we are going to have an Ethernet port. So using a cable, Ethernet cable, you can always connect it to your router that has internet capabilities. Alright, so if your router has internet, obviously then this device will also be able to access the internet. If your router does not have internet, if you are having some sort of LAN, local area network, then yes, internet capability will not be available. But yes, if internet capability is available, no matter where you are, using a mobile, using a laptop, you can always connect to your this device. Or you can make this device push some data through the internet onto your mobile or laptop. So this is how we take a day-to-day object or device and we can convert it into an IoT thing, so that it's capable of sending some message to you or receiving some message. It will also be capable of interfacing or interacting with other IoT devices. Say there is another IoT device, of course it is also going to have some sort of communication protocol. So now since this IoT device, this device has a communication protocol with it, it can communicate with other things as well. Okay, for instance, if I talk about a doorbell has been made an IoT device, right? So whenever the doorbell rings, okay, maybe it is going to send a signal to your camera. That is also an IoT device, and the camera will turn on and it is attached just on the top of the door, and you can see who has rung the doorbell. So something like that. So yes, the devices can communicate with each other also, and they can communicate with the users as well.